All right. So let's look at this. We've got the chain rule in this video. So let's look and see what the chain rule says. So it says if g is differentiable and x and f is differentiable at g of x, then the composite function f equals f circle g, defined by f of x is equal to f of g of x. Remember this from algebra. Okay, the composition is differentiable at x, and f prime is given by the product. Big F prime of x is equal to little f prime of x times g of x. I'm sorry, little f prime of g of x times g prime of x. And in Leibniz notation, if y equals f of u and u equals g of x are both differentiable functions, then dy dx is equal to dy du times du dx. All right, so what we're going to do here is we're going to work this problem, this example here, find the derivative, square root of x squared plus 1. We're going to do it writing it out like this, and we're going to work it again writing it out like this. All right, now this is the only problem in the whole video that we're going to work using this chain rule right here. All right, after we work this problem, we're going to go to this, the power rule combined with the chain rule, and this is how we'll work them from here on out. But I want to go over the chain rule for you, and then also at the end of the video, or towards the end of the video, we're going to work this problem again using this, the power rule combined with the chain rule. And then I'm also going to show you a shortcut for finding the derivative of a square root function, which is much easier than using the chain rule down there, or the chain rule combined with the power rule. All right, so let's go ahead and get started. So we've got, let's work it first with this, and then we'll work it again with this. All right, so we've got f of x is equal to the square root of x squared plus 1. All right, so remember, we had that f of x is equal to f circle g of x, which is equal to f of g of x. All right, so we've got to write this as two functions. All right, so the first one, I'm going to write f of u is equal to the square root of u, and then I'm going to write g of x is equal to x squared plus 1. All right, so if I take the composition of these two functions, all right, if I take the composition of the two functions, I'll end up with this. All right, because see, if I take the x squared plus 1 and I plug it in here for u, I get the square root of x squared plus 1. So all I'm going to do now is I'm going to take the derivative of this, and I'm going to take the derivative of this. All right, so I've got f prime of u is equal to, well, remember this square root of u is the same thing as u to the 1/2, right? So if I take the derivative of f of u, so f prime of u is equal to 1/2 times u to the negative 1/2, use the power rule, bring the 1/2 down, subtract 1 from the exponent, and so this is equal to 1 over 2 square root of u. All right, so I took the u to the negative 1/2, moved it down to the denominator, that changes it to a positive 1/2, and then I changed that u to the 1/2 to square root of u. And then also I get g prime of x is equal to, well, that's the derivative of this, which is just 2x. All right. All right, so let's see what we have here. So I've got f prime of x is equal to f prime of g of x times g prime of x. All right, so now all we're doing is we're plugging this in. And so this is equal to what? Well, f prime of g of x. So look at this. Here's g of x. You see that? And I'm looking for f, this little f prime of g of x. So that means this x squared plus 1, I'm going to put in the place of u. And so that's 1 over 2 square root of x squared plus 1. And then times g prime of x. And what's g prime of x? That's 2x. And so that's going to leave me with x over the square root of x squared plus 1. And there's your derivative. All right. Like I said, we're using this method on just this problem right here. Okay. All right. So what I did there is I used this right here. Okay. That's how I found the derivative of the square root of x squared plus 1. Now let's use this one right here. dy dx is dy du times du dx. All right. So what I'm going to do here is I'm going to let u, okay, see, so what I've got to do here is I've got to take the derivative of y with respect to u and the derivative of u with respect to x. All right. So I'm going to let u equal this part underneath the radical. So that's going to equal x squared plus 1. And I'm going to let y equal the square root of u. All right. So what does that give us? Well, now I'm ready to take the derivative of f prime of x. All right. So remember what it says. That's equal to dy dx times du dx. I'm sorry. dy du times du dx. All right. And then this big f prime of x, that's this dy dx here. Okay, it'd be the same thing if you had y equals that. All right. All right. So, well, let's find dy du. Well, what's dy du? That's the derivative of this, the square root of u. Well, we did that up here, didn't we? So when we had the square root of u and we took the derivative, that's 1 over 2 square roots of u. So that is going to be 1 over 2 square roots of u. And then du dx, that's the derivative of u with respect to x. That's just 2x. And then we make our substitutions. That's equal to 1 over 2 times the square root. What's u? U is x squared plus 1. And then du dx is what? Well, let's see, where is it? Du dx, that's 2x, so times 2x, and that's equal to x over the square root of x squared plus 1. And you can see we get the same thing. All right, so that's that. That's the chain rule. Now, the rest of the problems that we work, we're going to use the power rule combined with the chain rule. And this is how you will take the derivative. Okay, when you're working your problems and everything, that's how you're going to work them, is using this right here. All right, for the most part. Okay. All right. So the power rule combined with the chain rule. It says if n is any real number and u equals g of x is differentiable, then the derivative of u to the n with respect to x is equal to n times u to the n minus 1 times du dx. So this is like that power rule that you learned earlier in the course. The exponent comes down, subtract 1 from the exponent, and then it's times the derivative of this function right here. All right? So let me explain this rule a little more looking at this example. So basically what we have with the power rule combined with the chain rule is the exponent comes down. All right, so this is for when, like, you have something in parentheses raised to a power. All right, so something in parentheses raised to a power. So the exponent comes down, subtract 1 from the exponent, then it's times the derivative of what's inside the parentheses here. All right, so the derivative, the 100 comes down, and subtract 1 from the exponent. That's this part right here. Okay, exponent comes down, subtract 1 from the exponent. Then this right here tells us times the derivative of what's in the parentheses. So what's the derivative inside the parentheses here? 3x squared. And so we get 300x squared times x cubed minus 1 to the 99. And there's your answer. All right. It's that easy. Okay. It's not difficult to do at all. All right. What about this one? All right. So for this one, we could use the quotient rule, right? We could use the quotient rule there. But we're not going to. So when you've got something like this, now that we know the chain rule, if you can rewrite something as something to a power, then do it. Okay? So if you look at this, we can actually rewrite this as 1 over x squared plus x plus 1 to the 1/3. Which is x squared plus x plus 1 to the negative 1/3. Okay, so I just changed the cube root to a 1/3 power and then moved it to the numerator, which changes the sign of the exponent. So now let's take the derivative. So f prime of x, that's going to be negative 1/3 times x squared plus x plus 1. Subtract 1 from the exponent, which is negative 4/3. All right, so the exponent came down, subtract 1 from the exponent, times the derivative of what's inside the parentheses. So times 2x plus 1. And then I'm going to take this term here, move it to the denominator with the 3 to change this to a positive exponent. So I'm going to get negative, and that's 2x plus 1 over 3 times x squared plus x plus 1 to the positive 4/3. And there's your answer. All right. So see, that's not too bad, is it? It's not bad at all. All right. How about this one? All right, so we've got y prime is equal to 9 times x minus 2 over 2x plus 1 to the 8th. Exponent comes down, subtract 1 from the exponent. Then it's times the derivative of what's inside the parentheses. So we've got to take the derivative of this x minus 2 over 2x plus 1. Quotient rule, right? So let's do that. So the quotient rule, remember, that's the derivative of the numerator, which is 1, times the denominator, minus the derivative of the denominator, which is 2, times the numerator. All that over the denominator squared. All right. So let's see what we get here. So we're going to get 9 times x minus 2 over 2x plus 1 to the 8th times, and that's going to be 2x plus 1 minus 2x plus 4 over 2x plus 1 squared. And so you can see here the 2x's cancel out, and that's going to be 9 times x minus 2 over 2x plus 1 to the 8th times, and that's going to be 5 over 2x plus 1 squared. All right, so now let's do a little simplifying here. So you can see I've got 9 times 5, right? That's 45 times, let's do this, times, let's split this up. This is going to be x minus 2 to the 8th over 2x plus 1 to the 8th times 1 over 2x plus 1 squared. All right, see, there's a 1 there because I did the 5 times 9, so that's the 45 out here, so that's just 1 there. Now look at this, and remember that property from algebra that says a over b to the m, we'll use m, is a to the m over b to the m. And then remember, a to the m times a to the n is a to the m plus n. Like bases, you're multiplying, you add the exponents. All right, and so this is going to give us 45 times x minus 2 to the 8th over, and that's going to be 2x plus 1 to the 10th. And there's your answer. You see the 2x plus 1, that's like bases, add the exponents, 8 plus 2 is 10. All right. So hopefully you're getting all this. All right. So, I mean, as far as doing the chain rule, you know, how we're doing it now, as far as doing that, that's easy. The only thing that's going to get a little messy is just going to be the algebra part of it. All right. All right. So what about this one? All right. So here we've got the product rule, don't we? See that? We got the product rule. So remember what the product rule says. So if we're taking the derivative of f times g, that's the derivative of the first term times the second plus the derivative of the second term times the first. Okay, you might see it written a little bit different. This is just how I write it. I just do the derivative of the first function times the second function plus the derivative of the second function times the first function. All right. All right, so we've got y prime is equal to the derivative of the first function. So we've got to do the chain rule. It's 2x plus 1 to the 5th. We've got to do the chain rule. So that's 5 times 2x plus 1 to the 4th. 5 comes down, subtract 1, times the derivative of what's inside the parentheses. So that right there, that's the derivative of the first function. And then that's times the second function. All right. And then it's plus this part of it, the derivative of the second function, which is 4 times x cubed minus x plus 1 cubed. 4 comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses, 3x squared minus 1. So this is the derivative of the second function, and then that's times the first function. So now I got to do a little simplifying. All right. So let's look at this. So I've got y prime equals. Now I'm going to go ahead and just do this. All I'm going to do from this first step to this next step is I'm going to do the 5 times 2, and that's it. Okay. So I've got, and you can probably skip this step and go directly to the next step, but I'm just going to do it for the sake of this video. All right, so we got 2x plus 1 to the 4th times x cubed minus x plus 1 to the 4th plus 4 times 2x plus 1 to the 5th times x cubed minus x plus 1 to the 3rd times 3x squared minus 1. And I just rearranged these terms. All right. All right, so now what are we going to do? Well, now let's go ahead and factor out greatest common factor. So that's going to give me y prime is equal to 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 to the 3rd. All right, that was my common factor. You can see here the 10 and the 4, greatest common factor is 2. And then you see this term and this term, I just factored out at 2x plus 1 to the 4th. And then you can see this term and this term, I just factored out at x cubed minus x plus 1 to the 3rd. So when I factor this 2x plus 1 to the 4th, when I factor that term out, what am I left with on this term right here? Well, I'm going to be left with a 5, right? And then see this term, this is to the 4th, so that term's going to be gone. Here I'm factoring out this term to the 3rd, so I'll be left with just 1, and that'll change that exponent to a 1. So that's x cubed minus x plus 1. And then I've got plus. I'm factoring the 2 out, so for the 4th, I'm going to be left with 2. And I'm factoring out a 2x plus 1 to the 4th. So that means this 5th exponent will be changed to a first power, 2x plus 1. And then this term here to the 3rd, well, that'll be gone. And then I'm left with this one, 3x squared minus 1. All right. And so now all I have to do is just multiply this stuff out right here and combine like terms. So I get y prime is 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 cubed times, and that's going to be 5x cubed minus 5x plus 5 plus 2 times. Now here I need to full that out. So that's going to be 6x cubed. Is that right? Yeah. Now 6x cubed, and then minus 2x, and then plus 3x squared minus 1. All right. So this what I did here, I just took this right here, I got from multiplying those two binomials out. Now I got to distribute the 2. So y prime is 2x plus 1 to the 4th times x cubed minus x plus 1 cubed times 5x cubed minus 5x plus 5 plus, now that's going to be 12x cubed, I'm distributing the 2 now, minus 4x plus 6x squared minus 2. All right, now let's combine like terms in here. So that's going to be 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 cubed times, so that's going to be what, 17x cubed, and then I've got plus 6x squared. Okay, so let's mark some of this out. So that's that term and that term, that's the 17x cubed, and then there's the 6x squared. And then I've got minus 5x minus 4x. That's going to be minus 9x, and then 5 minus 2 is 3. And this is your answer. And yes, you need to simplify it this much. I'm sure that's what your teacher's going to want you to do. And if you're in my class watching this video, the answer to your question is yes, simplify it all the way down to this, right, what I just did. All right. It's not bad. It's like I said, it's algebra. Okay. The only part about this problem that's calculus is this first step right here. That's the only thing that's calculus. The rest of it's algebra. All right. Now, let's look at this. We've got derivatives of exponential functions. Now, I know you probably have already learned that the derivative of e to the x is e to the x, right? You've learned that already. Well, what if the exponent is not x? What if it's a function like, see the first problem here, e to the sine x? What do? Well, let's just go over e to a power. Let's go over that first, e to a power. Well, the derivative is just e to that power. See, we're just looking at this one right now. We'll look at this one in a minute. All right, so e to a power. What's the derivative? Well, it's e to that power times the derivative of the exponent. That's all it is. So e raised to a power. Okay, these are exponential functions, your variables in the exponent. All right, so e to a power. The derivative is just e to the power times the derivative of the exponent. All right. Now, one thing that you need to make sure you don't do, and I've had this done before, I've had students do this before, is that if you have something like e to the, well, it's not so much that they do it with e to the x, but like if they have something like the x in the variable, they'll want to bring that x down and subtract like that. You cannot do that. Okay? This is a big no. No, 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 don't do that. All right? That's this formula. See where the base is not e, it's some other number. All right, so let's find the derivative. All right, so y prime. All right, so it's just e to that power. All right, times the derivative of the exponent. What's the derivative of the exponent? What's the derivative of sine? Cosine. And so that's just cosine x e to the sine x. I just wrote the cosine in front, and there's your answer. All right, so let's look at the next one. All right, so what is this? This is y prime. It's just e to the power times the derivative of the exponent. What's the derivative of secant? Well, that's what? Secant tangent, right? Times the derivative of what we're taking the secant of. So what's the derivative of 3 theta? That's 3. And so we get secant 3 theta tangent 3 theta. Whoop, I forgot to put the 3 out in front of it. Let's put that 3 out there. Times e to the secant 3 theta. Okay, so I mean, that's all it is. That's it. That's all it is. It's just e to that power times the derivative of the exponent. That's it. All right, now this one. This is where this one we've got the base is not e. So let me just rewrite the formula down. So that's going to be Okay. So all I did is I just wrote this down again. Just wrote this down there so we could see it. All right, so what's the derivative? Well, let's see. Let's change the colors back. So I've got f prime of t is equal to, so that's just going to be 2 to the t cubed. Okay, it's just this written again. See, b to the u is just b to the u, so that's this, times the natural log of the base. Well, what's the base? The base of the exponent. That's 2. All right, times what? Times the derivative of the exponent. Well, what's the derivative of t cubed? That's 3t squared. And so this is going to be f prime of t is equal to 3 t squared times 2 t to the third natural log 2. And no, you cannot multiply that 3 and that 2 together. Okay? And that's your answer. So, I mean, you gotta remember this. You gotta remember this. All right. Now, one thing I want to show you here is let's just take let's take something simple. Let's say we've got y equals e to the x squared, and we want to take the derivative. Well, we know how to do that. Well, y prime is what? That's e to the x squared times the derivative of the exponent, right? And so that's going to give us 2x e to the x squared. Okay, that's based on, that's this formula right here. But, I mean, we're really using this formula here. Let me show you how we arrive at this with this formula. So instead of using this on that e to the x squared, let's use this one instead, and I'll show you. It might help you understand the formulas a little better. So I'm just going to take the derivative of this again. So that's going to be y prime is equal to e to the x squared times the natural log of the base, which is e, times the derivative of the exponent, which is 2x. Okay, so all I did, I used this right here. Well, you remember that's 1. Okay, because remember, natural log of e is equal to the log of e with base e. Remember, ln, that's log base e. And see, that's to the first power. And remember that property. If the base here and the base of the log are the same, your answer is just your exponent. And so that's y prime is equal to 2x e to the x squared. So you can get the same thing. Okay? It's just we don't write this step when the base is e. We're doing that step in our head. Okay, and we say, okay, there's a natural log e there, but that's equal to 1. And we just leave it at that. And that's why, and that's where, that's how we get that. That's where this is, because we know that natural log of e is equal to 1. All right, so what about this one? Let's take the derivative of this thing. That looks fun, doesn't it? All right, so I've got f prime of x is equal to, okay, so I'm taking the derivative of sine of this. So what's the derivative of sine? Derivative of sine is cosine, right? All right. Let's see, I need one more, don't I? All right, so the derivative of sine is cosine times the derivative of what you're taking the sine of. So it's times the derivative of this, right? Remember, whenever you take the derivative of those trig functions, the derivative of the trig function is whatever it is. In this case, derivative of sine is cosine. Then it's times the derivative of what you're taking the sine of. What am I taking the sine of? I'm taking the sine of all of this. So I've got to take the derivative of this. All right? So what's the derivative of cosine? Well, that's negative sine, right? See that? Times the derivative of what I'm taking the cosine of. See that? See this part right here, what I'm doing now, I'm taking the derivative of this, what's inside here. So the derivative of cosine is negative sine times the derivative of what I'm taking the cosine of. So that's times, and then the derivative of tangent is what? Secant squared x. All right? And so I get f prime of x is equal to negative cosine tan x sine tan x secant squared x. And that's your answer right there. All right. So, I mean, that one's not too bad. It's a little more, got to think about it a little more. It's a little messier, okay, but it's not bad at all. Okay, so here we go. Okay, this is our last problem. This is y equals the square root of x squared plus 1. So this was actually the very first problem that we worked. And remember, let's just go back up here and look. Now, don't stop the video. You want to watch this part. It's going to make your life a lot easier taking the derivative of square root functions. So when we took the derivative of it before, we used this and we used this. Okay, it's a lot of work right there. See that? And notice on the rest of the problems that we worked, I didn't do any of this. Okay, I used that power rule combined with the chain rule on the rest of them. This is what we did. All right, so when we're taking the derivative of square root of x squared plus 1, no, we can do this. Okay, we can do this right here, and that's what we're going to do the first time we work it. Okay, this is what we're going to do the first time we work the problem at the end. And then I'm going to show you a shortcut. All right. All right, so how would we do this? Well, we'll rewrite this thing as x squared plus 1 to the 1/2. All right. So the derivative, that's 1/2 times x squared plus 1 to the negative 1/2, right? The exponent comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses, which is 2x. All right, so that's, that's not bad. And so we get y prime, the 2's cancel, and I'm left with the x over. Now I'm going to take this and move it down to the denominator. That's x squared plus 1 to the positive 1/2, which is square root. And there's your answer, and you can compare it with the first problem that we worked. It's the same thing. All right, now let's come over here and write this problem down again. All right, and let's work it. Let's find the derivative. I'm showing you a shortcut. All right, so the derivative is, all right, so when you take the derivative, just draw your fraction bar. Now keep in mind, this only works with square roots. Okay, it only works with square roots. So this is going to be 2 times whatever the problem is. Okay? 2 times whatever this thing here is, square root of whatever. In the numerator, what goes in the numerator? The derivative of what's underneath the square root, which is 2x. And so you can see y prime is x over square root of x squared plus 1. And there's your answer. It's the same thing. And that's going to work every time on taking the derivative of square root functions. Okay? It only works with square root functions. It doesn't work with anything else. All right. So let's come down here and let's look at this. So y is equal to the square root of f of x. Okay. Let's do the formula. Okay. Let's work through this and get the formula. So I've got the square root of a function. Okay. So the square root of any function, of some function, here in this case f of x. All right. So y prime, actually what we're going to do, we're going to work this out this way so I can show you how that formula comes about. All right, so I got y equals, and that's going to be f of x to the 1/2 power. All right, and so y prime is going to be 1/2 times f of x to the negative 1/2, right? The 1/2 comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses here. So what's the derivative of f of x? That's just f prime of x. And so now this, I'm going to move down to the denominator. So y prime is going to be f prime of x over 2 times f of x to the positive 1/2, right? And so y prime is equal to f prime of x over 2 square root of f of x. And there's your formula there. You can see that whenever you have the square, you're taking the square root of some function, 2 times the square root of that function goes in the denominator, and then the derivative of what's underneath the radical goes in the numerator. And that's taking the derivative of a square root function. You know, use that. To me it's a lot easier. Remember my calculus teacher in college showed me that, and that's the only way I've ever taken derivative of square root functions. Okay, I mean, yeah, if you want to, you can write it out like this and do the chain rule if you want to, but to me this is much easier. It makes it a whole lot easier. It's quicker. Okay. All right, so I hope that video helped. And by the way, that's the last problem. I hope the video helped. Check out my other videos, but you know, look, you've learned it now. You've learned about derivatives. You've got, you know, the power rule, product rule, quotient rule, chain rule. That's what you got to know. You got to know how to do those. I mean, yeah, you're going to learn how to do derivatives of, you know, logarithms, and, you know, I mean, well, you learned exponential functions, but you're going to learn how to do derivatives of logarithms, and then, but that's just a formula. That's just formulas like your that's like your trig functions. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. Okay. But the procedures that you're learning, power rule, product rule, quotient rule, chain rule, that's it. That's the important stuff right there. Okay. That's what you've got to know how to do. And if you can do those, you're not going to have any problems taking derivatives. Okay. But you've got to know those. All right. So hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.